Hey there, welcome to this amazing session on how you can package your microservices into a jar file. So in this particular session, we are going to talk about packaging, and I would also want to let you know that this particular video is a part of a complete series. So if you are new to this channel or if you are watching my videos for the first time, I would highly recommend that you head over to the description and check out the link for the entire series. So this will help you get some context into the source code that is being used. Also, talking about what we are going to cover. So we are going to learn how you can package your microservices into a jar file that can be shared with others. So this is going to be an exciting session where we cover the same. So this is going to be a complete hands-on session where we will be actually doing things in a hands-on way practically. Now, if you have been watching my videos and if you haven't liked or subscribed yet, I would highly recommend doing so, because every subscriber or every subscription that I get on my channel motivates me to bring in more such amazing content for you all. The support and love that I get from my viewers impacts my ability to bring in more such amazing free content for you all. So I would highly recommend that you hit the subscribe button, like this particular video, and turn on the bell notifications. Also feel free to leave a comment to let me know what kind of videos I should bring for you all. Now, without a further ado, let's jump right into the session. Hello everyone, welcome back. So let us start talking about microservices packaging. So we all know microservices is a style of architecture wherein we have a collection of small loosely coupled services. And each of these microservices is deployed on a separate server. It is developed separately, deployed and scaled independently as well. But how do we get these services from our development environment to a state where they can be easily deployed, executed in a variety of environments like testing, staging, and production? And this is where packaging comes into picture. So let us first talk about how does a typical Spring Boot application executes or runs without any packaging. So what are the steps involved? So the number one step is the code compilation. So the first step is to ensure that your source code is compiled into bytecode, and this bytecode is .class file which is being used by the JVM, and the source files are compiled by Java compiler. Then the next step would be running the main class, and in Spring Boot application there is a main class which is annotated with @Spring Boot application annotation, and this serves as the entry point to the application. Then we talk about class paths and dependencies. So when you run the application without a jar, the class path must be set up correctly to include the compiled classes and any required dependencies. So the class path specifies the location where the Java runtime can find the necessary classes and resources. Embedded server. So if your Spring Boot application is a web application, the application typically includes an embedded web server, and when you run the main class, the embedded server starts and the application becomes accessible via HTTP endpoints. Source code changes. So since you are running the application from the source code, any changes you make to the code will take effect immediately upon rerunning the main class. So there is no need to rebuild the jar and restart the application. Then development mode. So running without jar packaging is convenient during development as it allows for rapid integration and testing of code changes. But for production environment, it's recommended to create a jar file. So these are the different steps that typically an application goes through when you're running it without packaging. Now, what is packaging? So packaging is a process of preparing your microservice for deployment. It involves compiling your source code into bytecode, bundling it with any dependent libraries, and creating a single executable artifact that can be easily distributed and run. Now, this artifact is what is called a package. Okay. So you can think of it something like this. So within the package, you have bytecode, dependent libraries, and the configuration. And packaging ensures that all the necessary components to run the service is gathered in one place in a format that's easy to distribute and execute. Now, what is jar? So when working with Java-based microservices, one of the most common forms of packaging is a jar file. So jar stands for Java Archive, and it's a file format that is used to bundle the components of the Java application together. And jar file allows us to package our compiled code, related libraries, resources, metadata, and the single file can be picked up by Java runtime environment and it can be executed. Now, packaging a microservices into a jar file can provide us with number of benefits. So the number one benefit is simplified deployment. So instead of dealing with numerous dependent files and classes, we have a single file that we can move around easily. Second, it ensures that all the dependencies are satisfied by including everything we need in our package. So this way we avoid the risk of missing libraries or other dependencies. And lastly, jar files can be executed directly by Java runtime, which simplifies the execution process. So to summarize, packaging and specifically packaging into jar files is a critical step in preparing our microservices for deployment. So it simplifies the process of transferring our applications between environments and ensures that we have everything we need to run our service. Now there are also other packaging options that exist, which is WAR. So this is like converting your application into a WAR file. And then we have EAR format as well. And then we have Docker image. So these are different packaging options also available. So that's all you need to know about packaging. Hey there, welcome back. So I wanted to talk a little bit about packaging basics. So in the world of Java, there are two primary build automation tools that dominate the entire landscape. And one is Maven and the other one is Gradle. And both these tools provide a comprehensive framework for managing the entire lifecycle of a Java project. And this includes packaging. So Maven is one of the earliest tools. It's one of the older tools that exists. And it uses this XML format that you can see. And it's a configuration file called pom.xml. And this is used to manage project builds. Now, POM stands for Project Object Model. Now, this outlines the unit of work in Maven. And it outlines the details about the project, what all the project needs, the configurations, and so on. Also, you can have defined packaging over here. So you can specify whether you want this application to be packaged as jar, war, or EAR file. And it takes care of the details without you having to worry about it. On the other hand, we have Gradle as well. So if you head over to the browser and if I open up Spring Initializer with Gradle, and if you say explore, you have this build.gradle file. Now, this is equivalent to the pom.xml file that we have in Maven. And this file takes care of having all the dependencies, the project definition, and so on if you are making use of Gradle as the build tool. Now, when it comes to packaging, the build file, so build.gradle is the build file in case of Gradle, and pom.xml is the build file when it comes to Maven. So when it comes to packaging, the build file specifies the format of the package and it becomes the entry point for the application. And with packaging, it also has any additional resources or definition that might be included in the package. So I wanted to just stress on the importance of having build tools when it comes to packaging. So here you have everything about the project now. So you have all the dependencies and what all your project needs on the runtime along with versions is specified over here. So that's the importance of build tools in packaging. Hey there, welcome back. So we need to start packaging our microservices. So what I'm going to do is I'm going to head over to Google and I'm going to search for Maven. Now here you can head over to the official Maven website and you can click on download here. So there are two ways of using Maven. So in order to package our microservices into a jar file, we will need to run few Maven commands. So you can either download Maven from here and get it installed on your system, but this is not what I'm going to do. So I'm going to use something called as a Maven wrapper. Now what is a Maven wrapper? So Maven wrapper is something that we get with Spring Boot application, okay? And we can use Maven commands without installing Maven then. So Maven wrapper is a shell script and a small binary that automatically downloads the correct version of Maven for your project and uses it to execute Maven commands. So with that step, we don't need to install Maven manually onto our system. Of course, if you want to, you're welcome to do so. But what I'm talking about is this wrapper over here. So you will see this .mvn file or .mvn folder which has the Maven wrapper in it. So we are going to make use of this. Now, before we start packaging, we need to understand a few Maven commands. So the number one command is mvn clean. So the clean command in Maven is used to remove all the files that are generated by the previous build. So if you are generating multiple builds and you might want to clean the files that are generated from the last build, you can use Maven clean. And this is because with every build, you will have some set of files that are being generated by Maven. So this is just for cleaning purpose. So running Maven clean will clean the target directory of your project, and which is where the Maven places all its build files. So if you see the project structure, you will have a target directory wherein all the files are being generated. So by files, I mean class files and jar files. The next command we should be aware of is Maven package. So package command compiles your source code and packages it in its distributable format. And the distributable format can be jar, var, or anything. So running Maven package will compile your code, run any tests if you have defined them, and then package your code into a jar file. And the resulting jar will be placed in the target directory of your project. Then we have Maven clean package. So this command combines the above two commands. So it will first remove all the files that are being generated by the previous build, and then it will compile your code and package it into distributable format. So these are some of the commands that you are supposed to be aware of. Now, here we are using mvn, but if you are using Maven wrapper, you don't need to use mvn. So there is a different way of executing commands using Maven wrapper, which we'll take a look at it shortly. But if you have installed Maven, you can use mvn, and the rest of the command remains same. So let us head over to IntelliJ. Now let us start talking about how can you start creating a package or a jar file. So what we are going to do is we are going to create a jar file for, let's say, company microservice. Okay. So what I will do is I will open up the terminal from here. This is the inbuilt terminal that I have within IntelliJ. Now here, I don't need to do any changes in pom.xml because I'm creating a jar file. Now, if you wish to create a file in some other format or some other packaging, you can have a packaging tag defined over here, and you can specify whatever you want to. So you can specify EAR, var, or you can even specify jar. But if you don't specify this, jar is the default. So I'll just remove this, and we have everything set up. We have the target folder created as well. Okay. Now target folder does not have the jar file. So let us open the command prompt and let us make sure that we switch over to the company microservice directory. So I'll check where I am. So I'll go to the company microservice directory. So I'll say company microservice. And here I'll start executing the command. So I'll say dot / because we are using Maven wrapper. I'll say mvnw. So this is Maven wrapper, and we'll say package. Now this will start the process over here, and you can see like there is a lot of activity that is happening over here, and there will be a lot of console logs that will be generated. Okay. So when you are running this particular command, just make sure that all the dependencies that your application needs are there. So for example, things like Zipkin server, RabbitMQ, or whatever it needs, like PostgreSQL database, everything is up and running. Okay. So here you can see the logs. So if I scroll up, you will see everything was scanned, and then pom.xml was taken into consideration. Okay. And here, if you go, it started generating the files. You can see it started compiling, and then your application tests were run. Now, your application was also started. Okay. So if you scroll down here, your application was running. Okay. And that is why we need all the dependencies. So your application might start, and then you saw quite a few logs. Okay. And your application was started. And then if you scroll down a bit here, you will see like everything was successful. And if you scroll down, you will see that the jar was generated over here in the target folder, and build was successful. So now if you go to the target folder here, you're going to see this jar file appear over here. Okay. So yeah, we have created our jar file. Now you can even validate the jar file after it's created. Okay. So I can run a simple command. I can say jar -tf. I can say target, and I can say company ms snapshot.jar, and I can say enter. Okay. So I'm not able to run this command jar. So I'm getting this error because I'm not able to run, or jar command is not recognized. And this is because I believe Java environmental variable path is not set for my system. So if you get this similar error, so what you can do is you can go to my computer, right click on my computer icon, and go to advanced setting, and over there you will find environmental variable option. So if I go over here, if I search for environmental variable here, so you can also go here from the search. So since I'm on Windows 11, I can search directly over here, and I can search for environment variables, and I get this pop-up here. Okay. So I can simply open this, or if you are not on Windows 11, you can go to my computers, right click, and you can choose properties. So on my computer icon, if you right click, you will see properties, and you can click on advanced system settings, and there you will see environmental variables over there. Okay. So on Windows, you can select environmental variables, and here you need to go to the path variable. You need to say edit, and here you need to add the path to JDK. Okay. So after adding, you might need to restart. Okay. So I'm not doing that. And if you ask me what is the path that I need to set, you need to set the path of Java installation, or the JDK path. So you need to go to program files. So here, if I go to program files, I have it installed. So Java is installed in Java folder within program files, and there you have JDK 20. Now within JDK 20, you will have this folder bin. Now here you will have this file jar.exe. So this is what we are using here. Okay. So you need to copy this path and add to this path variable over here. Okay. This path variable. So I'm not doing that, but as an alternative, what I'll do is I will run it using another way. So I have the command created. So this is the path of the jar file. Okay. So what I'm doing is in PowerShell, I'm passing in the entire path of jar.exe along with the and variable, because this is because I'm using PowerShell, and you can pass the rest of the command as it is. Okay. But if jar command works for you, you can just specify jar. And if you're not using PowerShell, you can also use something like this. So you can simply say something like this. So in PowerShell, you will need AND operator, but if you're not using PowerShell, this should work for you. Okay. So I'm going to copy this first command and I'll go over here and I'll paste it. Okay. And now once you paste this, you can see like everything within your jar. Okay. So if you scroll up and you will see all the contents of your jar file. Okay. And if you see over here, you will see everything that your jar file has. Okay. So this is to confirm that everything is working as expected. Okay. And you're just checking if everything exists in your jar file. Now, what you can also do is you can run your jar file, okay, right from the command line. Okay. You can run this project. Now, how would you run your project from here? So the answer is with the help of jar file. So it is an executable jar, right? So we'll say Java. Okay, something went wrong. So I'll just clear my screen here. I'll say Java and I'll say over here -jar. So since we are running a jar file, we need to specify -jar. And now we'll specify the path of the jar over here and we'll say run. So you can see the application is running now, okay? And I believe it won't run, so it will shut down. And the reason is because our port is already engaged. And who is engaging this port? So I have the company microservice already running from IntelliJ. But if you stop this and if you start from here, okay, the port 8081 will be freed up and it will be in use by this particular service. So this way you can get your jar to execute, and this is the process that we went through. So I hope you found this entire process easy to set up and easy to follow. So that's about jar files with microservices. So let us test the functionality of our application that has been packaged into the jar file. So what I'm going to do is I'm going to go to services and I'm going to turn down the company microservice application. Okay. So this application is down. Now I'll try running the application right from the terminal. So I'll type in the command. I'll say Java -jar and I'll say target /company snapshot.jar and I'll press enter. So now you see the application is running. We'll wait for a while and we hope we don't get any errors. So the application is running. Also make sure before you run the application, you have all the dependencies up and running, like the PostgreSQL, Zipkin server, RabbitMQ. So whatever this application needs. Now let us head over to browser and here I'll go to Eureka. Okay. And we'll see that company service is now registered with the Eureka server. And you can even send some requests. So I can like get companies. I can post a company. Okay. And it will give me the list of companies. So it is working perfectly fine without any issues. You can see here, we created a new company and we are also able to get that particular company here. Okay. So rating is coming in as null. So I need to update the rating here like so. So I'll say 5.0. Okay. And I'll add a comma here. So I'll create this company. And now if I try to get, you'll see company with rating. So this is indeed working perfectly fine as if you are executing the project directly.